Hello physics students, this is Mrs. Peachy from your WCA physics class. Today I'm going to walk you through Unit 4, Lesson 4, Thermal Equilibrium Portfolio. This, believe it or not, is already your final portfolio for first semester. I know it's kind of hard to believe we've come this far already. This is also by far not my favorite subject when it comes to physics. And as far as the labs are concerned, this one does tend to be a bit more, I wouldn't say difficult necessarily, but the directions aren't necessarily the clearest either. So we'll try to go through it a little bit together and see if it makes a bit more sense to you that way. So you're going to go to, let's see, I think it's slide 2 here. Nope, that's not it. That tells you the grading rubric. Here we go, it's on slide 3. But I wanted to caution you because this grading rubric is not the rubric that we use, and it hasn't been the rubric we've used all year. So some of you are still not including some of the required information from that, and I just want to make sure that you realize that you do have a separate grading rubric. On my website, when you go to the physics page, you will find a lab rubric right up there on top, and it gives you a lot more specifics on what need to be included within your write-up. So make sure you do have all this stuff here if it's called for. And as I usually tell you during these video tutorials, if the graph, the data is graphable, then you should be graphing. Okay, so even if the lab itself does not tell you to make a graph, if your data is something that can be expressed in a graph, you should make sure you make one so that we can see any relationships that might exist. It's just kind of a given when it comes to analyzing your physics data. All right, so clicking on slide 3, the link to the Thermal Equilibrium Lab, it brings you to this page. And at the bottom, it'll say Go to Lab, and that's where we need to do. You're going to be completing labs 1, 2, 3, and 4 at the top here, experiment 1, 2, 3, and 4. And all of your information will be, of course, given in a lab report that you'll write up for me. But there's also additional information and instructions that are in this little link that says lab report. Okay, but it doesn't give you everything that you need here. So, as I said to you before, it's a bit on the disorganized side. Going back to your lesson, keep in mind that just like with most of your portfolios, and I'm sorry I went the wrong way here, you do have to begin with a hypothetical for this one. So your hypothetical experiment, it says, in this lab you will place 2 objects with different temperatures next to each other. You will observe how different materials and different masses affect the rate of heat flow. As your textbook explains, thermal equilibrium occurs as a result of the heat energy transfer between 2 objects with different temperatures that are in physical contact with each other. Heat is defined as transfer of energy due to a difference in temperatures. In this lab, you will study how thermal equilibrium occurs when 2 objects at different temperatures are placed in physical contact with each other. So you, as a hypothetical experiment, need to design something that you might be able to do in real life that would demonstrate thermal equilibrium, or the transfer of heat and coming to a state of thermal equilibrium. You would describe what materials you'd use, what you'd measure, how you'd measure it, what results you'd expect, and really what would it indicate if your results weren't what you expected. Now what that means is you're going to be searching for sources of error that you may have within your experiment. And again, I reiterate to you that human error is not an acceptable source of error. Humans can make lots of errors. So you need to describe what errors a human could actually make. Are there errors in measurement? Are there errors in calculation? Are there errors in lab setup? Would there be errors in perhaps equipment failure? Perhaps there would be unintended variables that may occur. So identify what these might be and make sure you are explaining them. And the second part of this is that you need to make your hypothesis. So your hypothesis in this case is thinking about these questions. How will the difference in temperature of the two objects affect its final temperature? How will the masses of the two objects affect its final temperature? And how will the composition of the objects affect the final temperature? So knowing what you've read already within your lessons and within your text, you will make a hypothesis about these three questions. Don't forget that when you are making your hypothesis, you should refer back to the text and you should cite within your hypothesis parts of the text that support your thoughts on this, okay? So it should not just be a guess. It's an educated guess, which is a really poor description of a hypothesis, but it really means that you need to have some background information first. So make sure you are giving us some text-based evidence to support why you picked the hypothesis that you did. Once you've done that, then it's going to take you to that thermal equilibrium's lab again. And that's, again, the wrong one. I'm getting in. There we go. Too many screens up at once again. So you're going to actually be able to click and drag these things onto the table and put a copper rod to connect them. Yeah, it's a little piggy sometimes. There we go. And you can put thermometers in, each one. And then you can click on the start button and it will tell you what the initial temperature of each block is and the final temperature of each block in both degrees Celsius and degrees Fahrenheit. So I'd like you to report your answers in degrees Celsius, okay? So we start with an initial temperature of 100 degrees Celsius and 0 degrees Celsius. And then we kind of wait here. As time passes, the temperatures change. Note you don't know how long time is passing at this point. You could assume that this is in real time, but we can't make that assumption at all. We can't know for sure how much time is actually passing. So you don't need to use a stopwatch or anything to be able to time this. Okay? At some point, it will come to a state of thermal equilibrium. And that means the temperature should be equal on both sides. Okay? And now it says you've completed the experiment. So you have the data here of the initial temperatures, the final temperatures. You have the mass of both objects. And you have the composition, which is going to be something we will use because we'll need to have the specific heat of the two different objects. Okay, so this is copper, and each type of material has a different specific heat or different heat capacity. So you're going to have to look that up in a table in your textbook, and it will tell you, basically, it tells you how much energy it uses or how much energy is needed for it to change temperature. Okay, that's what the heat capacity is. So you'll need that information as well to complete the analysis portion of this. Second experiment, you do the same thing, but now you've got two different size cubes, so the masses are going to vary. Third experiment, same thing, but now you've got two different compositions of two cubes, so your specific heat will vary. And with the fourth experiment, it is both mass and specific heat will be different, so that's why things will be different. Okay, so once you've completed all of the data collection, then you need to go on to the data analysis portion, and that's where we're going to go back to your lesson. So you'll be using the equation Q equals MC delta T, okay? And Q is like the quantity of energy, essentially, that is there. It's a heat. Heat is the energy. And M, mass, C is your specific heat, and delta T would be your change in temperature. And you'll be able to then answer these conclusion questions based on the analysis. Don't forget to include all of your calculations within your analysis section, okay? So you're going to answer those three questions again. How does the initial temperature affect the point of thermal equilibrium? How does the composition affect thermal equilibrium? And how does mass affect it? Okay? If you need help going through these calculations with me, that is totally fine, and you can just give me a call or send me a webmail and we can set up an appointment in my classroom. Or I guess if not, then good luck with everything, and hopefully you will do a great job on your final portfolio for the semester. Thank you, everybody. Have a great day.